All right, let's talk about something you've probably typed 1,000 times without even thinking about it. I'm talking about N vs ENDL. Now, on the surface, this seems like a super simple question, right? But the answer? Well, the answer is key to understanding how your code really works under the hood.
You know, in programming, you run into this all the time, especially when you're starting out. You find two completely different ways to do what looks like the exact same thing. And that always leads to a great question. I mean, just look at this. On one side, we've got our good old \n. On the other, we've got endl. And the result? It's exactly the same. They both just move the cursor down to the next line. So what's the deal here? Why have both?
And that right there, that's the million-dollar question, isn't it? The people who design these programming languages, they're not just throwing things in there for fun. They don't add extra stuff unless there's a really, really good reason. There has to be some kind of invisible difference, something powerful going on behind the scenes. And that's exactly what we're going to dig into.
Okay, so to get our answer, looking at what just pops up on the screen isn't enough. We have to go deeper. We need to pull back the curtain and see what's happening backstage every single time you tell your program to print something. And that brings us to this idea of the output buffer.
So what on earth is an output buffer? The easiest way to think about it is like a waiting room. It's a temporary holding spot. Before your text actually shows up on your monitor, the program sends it to this little waiting area first, kind of getting everything lined up and ready to go.
Now, this whole process usually happens in the blink of an eye. It's so fast, you probably don't even know it's there. But, and this is the important part, understanding this hidden little mechanism, that's what separates good programmers from great ones. It's how you really level up.
And believe it or not, the entire difference between N and endl comes down to how they treat this waiting room, this buffer. It all hinges on one single action, something called flushing.
Okay, this table makes it super clear. Look at the first job. Inserts a new line. Both of them do that. No difference. But check out that second row. See how N line has nothing? And L, on the other hand, has a second job. And there it is in bold. Flushes the output buffer. That's the whole secret.
So what does flushing the buffer even mean? It's basically kicking everyone out of the waiting room immediately. It's telling the system, hey, whatever text you're holding on to right now, I don't care if you're ready, just push it all to the screen. Right now.
Let's look at N first. It's the patient one. When you use it, the text goes into the buffer, and it just chills. It waits for more text to come along. It's happy to wait until that buffer is totally full, and only then does it send everything to the screen in one big, efficient package. But endl? Oh, endl has zero patience. It puts a line of text into the buffer and immediately yells, "Get it out there! Flush!" It forces the screen to update right that second, and then it does the exact same thing for the next line, and the one after that, every single time. So at this point, you might be thinking, okay, that's a cool little technical fact, but who cares? Why does this matter in the real world? Well, it matters a ton when performance is on the line. Let's imagine a situation where this tiny difference suddenly becomes a huge deal.
Okay, let's set the stage. Forget about printing just 1 or 2 lines. Imagine your program needs to spit out 1,000 lines of text. All of a sudden, that impatient behavior we talked about is going to have a massive, and I mean massive, impact.
If we use endl to print those 1,000 lines, think about what we're asking the computer to do. We're telling it, print a line, then flush. Print a line, then flush. Over and over again. That's 1,000 separate flush commands. And each one of those commands, it takes a little bit of work, a little bit of time.
Now let's flip it and look at N. It's so much smarter for this job. It just gathers up all 1,000 lines in the buffer, one after the other, doing all the hard work behind the curtain. And then, only when it has everything, does it do one single flush to put it all on the screen. See the difference? 1,000 operations versus just one.
So the takeaway here is pretty clear, right? When you're printing a ton of stuff, N is way more efficient. That flushing operation isn't free. It costs time. And doing it 1,000 times instead of just once, yeah, that adds up fast. And this is where we get to the real heart of the matter. Because this isn't just about shaving a few milliseconds off your program's runtime. It's bigger than that. It's about changing how you think as a programmer.
So the obvious question is, all right, I get it. N is faster, so I should just always use N, right? It seems like the obvious choice, but it's actually not that simple.
Here's the thing. Neither one is better. They're just different tools for different situations. Think about it.
If you're writing a huge amount of data to a log file, yeah, you absolutely want the performance of endl. But what if you're writing a program that asks the user a question, like, enter your name? You need that question to show up on the screen immediately, right? You can't have it sitting in a buffer. In that case, the instant flush you get from endl is exactly what you want.
And that's the real lesson here. It's not about memorizing a rule like always use n. It's about understanding the why behind the tools you use. Knowing when you need performance versus when you need immediacy. That is the kind of deeper knowledge that really separates you from the pack.
At the end of the day, great programming isn't just about getting the code to work. It's about understanding how it works. It's about seeing those invisible gears turning in the background like the buffer and knowing how to make them work for you. That's what being an expert is all about.
So I'll leave you with this to think about. What else is in your code? What other simple, everyday commands are you using that have this same kind of hidden depth?